Welcome to the DIY Honda Garage channel. Welcome to the Diagnostic Troubleshooting Guide for DTC P0139, which refers to the secondary heated oxygen sensor, specifically its slow response in the 2023 Plus Honda CR-V. The secondary heated oxygen sensor, or secondary HO2S, is crucial in monitoring the exhaust coming from the engine. Located downstream of the catalytic converter, it plays a vital role in determining if the catalytic converter is functioning correctly. When the output voltage from the secondary HO2S does not vary during feedback control, the powertrain control module, abbreviated as PCM, detects this abnormality, triggering the DTC. You should ensure to check the emission system, as leaks in the exhaust can also cause this code to set, affecting the sensor's performance. We'll go through the steps to diagnose and resolve this issue efficiently. DTC P0139 indicates an issue with the secondary heated oxygen sensor, also known as sensor 2. This sensor's primary role is to track the exhaust gas composition after it passes through the catalytic converter, ensuring that the converter is operating properly and efficiently. The sensor is situated downstream of the converter, meaning it measures the exhaust gases that have been filtered to assess the converter's effectiveness. If the output voltage from this sensor remains constant instead of fluctuating as expected, the PCM flags this as an abnormality and stores the DTC. It essentially assesses whether the fuel is being burned correctly and helps manage air-fuel ratios to maintain optimal engine performance. If any leaks in the exhaust system are present, they must be checked and repaired, as these can severely affect the sensor's operation. There are several potential causes of DTC P0139 that technicians should consider. First, a faulty secondary heated oxygen sensor itself can lead to inaccurate readings, triggering the DTC. Secondly, any leaks in the exhaust system can alter the gas composition before it reaches the sensor, skewing its response. Another possibility is issues with the powertrain control module, PCM, which might misinterpret the data from the sensor. Furthermore, there may be problems with the wiring or electrical connections associated with the secondary HO2S, which can impair signal transmission. Each of these causes must be examined systematically in order to accurately diagnose and address the problem at hand. Several symptoms can accompany DTC P0139, which can help in identifying the issue. One of the most noticeable signs is the illumination of the check engine light on the dashboard, indicating a potential fault within the emission system. Additionally, a malfunctioning secondary HO2S can lead to deteriorated fuel economy, as the engine management may not be optimizing air-fuel ratios correctly, leading to inefficient combustion. Drivers may also experience rough engine performance, including hesitation during acceleration or uneven running due to improper readings affecting fuel delivery. Recognizing these symptoms early can prompt timely diagnostic action, potentially preventing further damage or degradation of vehicle performance. The first step in troubleshooting DTC P0139 is to start the engine and establish a controlled condition to assess the performance of the secondary HO2S. Once the engine is running, hold the engine speed at 3,000 revolutions per minute, or PM, without any load, meaning the vehicle is in either park or neutral. This simulated testing condition allows the system to reach an appropriate temperature and operational status. During this process, be sure to check the radiator fan. It should activate based on the engine temperature. This ensures the cooling system is functioning correctly, which is essential for accurate readings from the exhaust system. If the fan operation is abnormal or fails to engage, it could contribute to overheating or other sensor issues. Next, we proceed to test drive the vehicle while closely monitoring several key conditions. Ensure that the HDS, or Honda Diagnostic System, shows that the ECT sensor 1 is reading at least 158 degrees Fahrenheit, which is approximately 70 degrees Celsius. This temperature indicates that the engine is sufficiently warmed up and that the components are working within acceptable parameters. During the drive, maintain a steady speed between 55 to 75 miles per hour or 90 to 120 kilometers per hour for a continuous 1-minute period. Consistent speed is critical to evaluate how the secondary HO2S reacts under normal driving conditions. This performance check allows you to identify any abnormalities in the sensor's response when exposed to regular operating scenarios. After maintaining a constant speed, the next step in troubleshooting is to decelerate the vehicle. This action should be done with the throttle fully closed, allowing the vehicle to slow down naturally. It's vital to engage in this deceleration for a duration of over 10 seconds. This condition mimics potential real-world driving scenarios, where the engine shifts from a high power demand to a lower power demand. During this period, the PCM will monitor how the secondary HO2S adapts to the changes in exhaust gas composition. It's important to ensure that this deceleration is smooth and consistent, which will provide clearer data and assist in identifying whether the sensor is performing correctly during transitional states of engine load. The fourth step involves confirming the HDS reading for the catalyst temperature. After the deceleration and subsequent conditions have been met, ensure this reading reflects a value above 842 degrees Fahrenheit or 450 degrees Celsius. This temperature is a critical threshold that indicates the catalytic converter is reaching the necessary operational effectiveness. If the measurement falls below this threshold, it suggests that the catalytic converter may not be functioning as intended, or that there are further underlying issues. If this occurs, you should repeat the previous testing steps several times to ensure that the readings remain consistent. Adjustments to the engine conditions can provide additional insights into the performance status of both the secondary HO2S and the catalytic converter. The final troubleshooting step involves closely monitoring the HDS under the OBD status system to check for the DTC P0139 code. This process is essential in confirming whether the troubleshooting steps have resolved the earlier issues. The OBD status is a critical indicator that provides real-time data regarding emissions system performance and whether any fault codes are present. If the P0139 code reappears, it suggests that further issues persist with the secondary HO2S, wiring, or the PCM's interpretation of the data. In contrast, if the status shows no faults, this indicates successful diagnostics and resolution of the problem. Cleansing any previously recorded DTCs should also be performed to confirm that the system checks out fine, without old fault codes lingering. Upon completing the troubleshooting steps, it is crucial to conduct a final verification to ensure that all repairs have been effectively implemented. Begin by re-inspecting all related components, including the secondary HO2S and any wiring or connections, to confirm that everything is secure and in optimal condition. If all inspections meet quality standards and no issues are present, proceed to clear the DTC from the PCM. This resetting process ensures that the vehicle's computer can accurately monitor for any new codes. Lastly, it's essential to test drive the vehicle again under similar conditions to those used during initial diagnostics, allowing the technician to evaluate any changes and confirm that the repair has resolved the problem. To prevent future occurrences of DTC P0139, regular maintenance is essential. Conducting periodic inspections of the exhaust system is paramount. This includes checking all piping, joints, and connections for leaks. Small exhaust leaks can significantly affect the performance of the secondary HO2S and lead to erroneous readings. Additionally, monitoring the life cycle of your sensors is important, as they can become less effective over time. Replacing aging sensors proactively can ensure that the emissions system operates efficiently, preventing delays or additional repairs down the line. By prioritizing these preventive measures, you can enhance the longevity and reliability of your vehicle's emissions management system. In conclusion, understanding DTC P0139 is crucial for maintaining the performance of the Honda CR-V. This code typically points to issues with the secondary heated oxygen sensor's response, significantly impacting the vehicle's emissions and efficiency. By closely following the diagnostic steps outlined here, technicians can efficiently identify and address the root causes of this error code. It's equally important to monitor the overall health of the vehicle's exhaust system and address any leaks or component failures promptly. By adhering to these guidelines, you can help ensure that your vehicle remains in optimal working condition while maintaining compliance with emission standards. Awareness and proactive management of your vehicle's systems can lead to better performance and longevity. Please like and subscribe to the channel. See you next time.